Chapter 1.3.1 Images. A container image is a binary data package that contains an application and all its dependencies. These images are standalone, executable software bundles that are designed to run in a specific runtime environment. To use a container image in a Kubernetes pod, you must create the image of your application and push it to a registry. This page offers an overview of container images and their use in Kubernetes. For specific container images for a Kubernetes release, such as v1.31, you can visit the Download Kubernetes page. Image names. Container images in Kubernetes are typically named using formats like POS, example mycontainer, or kube API server. These images can also include a registry hostname, such as fictional.registry.example/imagename, and a port number, such as fictional.registry.example10443/imagename. If no registry hostname is specified, Kubernetes defaults to using the Docker public registry. The behavior can be changed by setting the default image registry in the container runtime configuration. Tags and digests are used to identify different versions of images, with digests being immutable and representing a specific version of an image. Tags can be moved to point to different images, whereas digests remain fixed. Image tags follow a specific regex pattern and can be up to 128 characters long. If no tag is specified, Kubernetes assumes the tag is latest. Examples of image names that Kubernetes can use include BusyBox, BusyBox132.0, registry.k8s.io/pos-latest, and registry.k8s.io/pos3.5. Digests consist of a hash algorithm and a hash value, providing a unique identifier for an image. Only the digest will be used for pulling in cases where both tag and digest are specified in the image name. Updating images. When creating a deployment, stateful set, pod, or any other object that includes a pod template, the default image pull policy is set to if not present, if not otherwise specified. This policy dictates when the kubelet attempts to pull the specified image based on the image pull policy set for each container in the pod. The values that can be set for image pull policy are if not present, always, and never. If not present pulls the image only if it is not present locally. Always queries the image registry every time to ensure the latest image, and never does not try to fetch the image, leading to a failed startup if not present locally. Using the latest tag for images can make tracking versions difficult, so it is recommended to use a meaningful tag or digest for better version control. Using image digest ensures that the pod will always use the same version of the container image, even if the registry code changes. Third-party admission controllers can mutate pods to use image digests instead of tags, ensuring consistent code versions across the cluster. The default image pull policy is automatically set based on certain conditions when submitting a new pod to the API server. If the image pull policy is omitted, it defaults to if not present if the digest is specified, always if the tag is latest, and always if the tag is not specified. The image pull policy is set once when the object is created and does not update if the image tag or digest changes later. To force a pull of the image pull policy can be set to always, or the latest tag can be used to automatically set the policy when the pod is submitted. The image pullback off status occurs when Kubernetes cannot pull a container image, leading to a delay in attempts to pull the image. Kubernetes also supports alpha support for performing image pulls based on the runtime class of a pod. Enabling the runtime class in Image Cry API FeatureGate allows for referencing container images based on both the image name and runtime handler, providing more control and adaptability for different container runtimes. This feature can be particularly useful for VM-based containers like Windows Hyper-V containers. Serial and parallel image pulls. By default, Kubelet pulls images serially, meaning one image pull request is sent to the image service at a time. Nodes make image pull decisions in isolation, so two different nodes can pull the same image in parallel. To enable parallel image pulls, the field serialize image pulls needs to be set to false in the Kubelet configuration. This allows multiple images to be pulled at the same time. However, it is important to ensure the image service of the container runtime can handle parallel image pulls. The Kubelet does not pull multiple images in parallel for one pod, but will do so for different pods when parallel image pulls is enabled. In Kubernetes v1.27 alpha, the maximum number of parallel image pulls can be set to limit network bandwidth and disk I/O consumption. This can be done by setting the field max parallel image pulls in the Kubelet configuration to a positive number equal to or greater than 1. If max parallel image pulls is set to 2 or higher, serialize image pulls must be set to false to avoid startup failures. Multi-architecture images with image indexes. A container registry can provide a container image index, which can point to multiple image manifests for architecture-specific versions of a container. This allows for different systems to fetch the correct binary image for the machine architecture they are using. Kubernetes typically names container images with a suffix $$ for backward compatibility, allowing older configurations or YAML files with hard-coded images to still work. This ensures that different systems can access the right binary image based on their architecture. Using a private registry. Private registries may require keys to read images from them, and credentials can be provided in several ways. One method is to configure nodes to authenticate to a private registry, requiring node configuration by the cluster administrator. Another option is to use the Kubelet credential provider to dynamically fetch credentials for private registries using a plugin for the respective private registry. Pre-pulled images can also be used, allowing all pods to use any images cached on a node. Additionally, specifying image pull secrets on a pod allows only those pods that provide their own keys to access the private registry. Vendor-specific or local extensions can also be implemented to authenticate nodes to the container registry. Configuration instructions for setting credentials depend on the container runtime and registry being used, with specific guidance available in each solution's documentation. The interpretation of config.json can vary between Docker and Kubernetes, with Kubernetes allowing more flexibility in specifying URLs and paths. Configuring nodes to authenticate to a private registry can vary depending on the container runtime and registry being used, with specific instructions provided in the solution's documentation. The Kubelet credential provider is recommended for authenticated image pulls, particularly for cloud providers with short-lived auth tokens. Pre-pulled images can be used if node configuration can be controlled, but may not work reliably if nodes are managed automatically by a cloud provider. Specifying image pull secrets on a pod is the recommended approach for running containers based on images in private registries. Pods can reference image pull secrets in their own namespace, and secrets must be of type kubernetes.io/dockercfg or kubernetes.io/dockerconfig.json. The creation of a secret with a Docker config involves knowing the username, registry password, client email address, and hostname for authenticating to the registry. Overall, the use of image pull secrets, pre-pulled images, and Kubelet credential provider are effective methods for authenticating pods to private registries in Kubernetes environments. The specific approach chosen will depend on the level of control over node configuration and the requirements of the private registry being used. There are various solutions for configuring private registries, depending on the use case. For clusters running only open-source images, public images from a public registry can be used without any configuration required. Some cloud providers automatically cache or mirror public images to improve availability and reduce image pull time. For clusters running proprietary images that should only be visible to internal users, a hosted private registry or an internal private registry behind a firewall can be used. For clusters with proprietary images that require stricter access control, the Always Pull Images admission controller should be active to control image access. In a multi-tenant cluster, each tenant can have their own private registry with authorization required by generating registry credentials for each tenant and populating them to each tenant's namespace. Secrets can also be used to store sensitive data instead of packaging it in an image. Legacy built-in Kubelet credential provider. In older versions of Kubernetes, the kubelet had direct integration with cloud provider credentials, allowing it to fetch credentials for image registries dynamically. This integration included ACR, ECR, and GCR. However, Kubernetes versions v1.26 to v1.31 no longer include this legacy mechanism. To work around this, users can configure a kubelet image credential provider on each node or specify image pull credentials using image pull secrets and at least one secret.